In the heart of our cosmic neighborhood, a star reigns supreme. Sol, our sun, it holds our solar system together, an immense sphere of incandescent plasma, dictating the dance of planets with its colossal gravity. Its light and heat are the lifeblood of Earth, the very reason we are here. But what is this magnificent star? Where did it come from? And what will be its ultimate fate? Join us on a journey into the heart of a star. Our story begins 4.6 billion years ago. In a vast, cold cloud of gas and dust, a stellar nebula, gravity began its patient work. A dense core formed, pulling in more and more material, spinning faster, growing hotter. The pressure and temperature at its center became so extreme that a miracle of physics occurred. Nuclear fusion ignited. A star was born inside the sun's core. Temperature soared to 15 million degrees Celsius. Here, hydrogen atoms are fused into helium through a process called the proton-proton chain reaction. This releases a staggering amount of energy in the form of photons, particles of light. But a photon's journey out is not a straight line. It's a random walk, a chaotic journey that can take over 100,000 years. It bounces through the radiative zone before being carried upward by churning currents of hot plasma in the convective zone, like bubbles in a boiling pot. Finally, this energy reaches the sun's visible surface, the photosphere. This surface isn't smooth. It's a seething, granular pattern of bright, hot cells rising and cooler, darker plasma sinking. Dotted across this surface are sunspots, cooler, darker patches caused by intense magnetic fields bursting through. These magnetic flux tubes twist and snap, unleashing tremendous energy. Above the surface lies the sun's mysterious atmosphere. First, the chromosphere, and then a bizarrely thin transition region where temperatures suddenly leap. This leads us to the sun's ethereal crown, the corona, visible during a total solar eclipse. This halo of plasma reaches millions of degrees, far hotter than the surface below. How the corona gets so incredibly hot is one of the greatest unsolved mysteries in solar physics. The sun's magnetic activity also drives space weather. Sometimes its magnetic field lines snap and reconnect, releasing a burst of radiation called a solar flare. Other times, it ejects billions of tons of plasma into space in a coronal mass ejection, or CME. If aimed at Earth, these events can disrupt our satellites, power grids, and communication systems. A powerful reminder of our star's untamed nature. A constant stream of charged particles, the solar wind flows from the sun in all directions. Fortunately, Earth has a shield. This magnetic field deflects most of the solar wind, but some particles get trapped and funneled toward the poles where they collide with our atmosphere. The result, the most spectacular light show on Earth. The aurora borealis in Australia's back on Earth. The sun is the ultimate life. Its energy powers photosynthesis, the foundation of nearly all life. It drives our climate and weather. Over long timescales, subtle shifts in Earth's orbit, known as Milankovitch cycles, change how much solar energy we receive, triggering ice ages and warm periods. Our world is shaped and sustained by this distant, fiery star. But our sun, like all stars, will not burn forever. In about 5 billion years, it will exhaust the hydrogen fuel in its core. It will then begin to swell, becoming a red giant, engulfing Mercury, Venus, and possibly even Earth. Its outer layers will drift away, forming a beautiful planetary nebula. At the center, all that will remain is the sun's cooling core, dense, Earth-sized remnant known as a white dwarf, destined to fade slowly into the cold darkness of space. From its fiery birth to its quiet end, the sun is more than just our star. It is a cosmic laboratory, a window into the processes that govern the universe. By studying it, we learn not only about our own world's past and future, but also about our place in the grand stellar tapestry. It reminds us that we are part of something vast, ancient, and truly magnificent. Thanks for
Welcome to Mercury, the smallest and swiftest planet in our solar system, tucked dangerously close to the massive, glowing sun. At first glance, it appears like a desolate gray twin of our moon, scarred by eons of heavy cosmic impacts. This tiny world orbits so fast that a single year lasts only 88 Earth days, racing through the void of space. To see it transit across the sun is to realize just how small and resilient this planet truly is. Look at the Caloris Basin, an enormous impact scar so large it could contain several of Earth's largest nations. Rugged mountains and ancient lava-filled plains tell the story of a world with a surprisingly violent and volcanic past. This is a land of impossible extremes, where the sun shines 10 times brighter than it does on our home planet. On the day side, temperatures reach a blistering 800 degrees Fahrenheit, hot enough to melt lead with ease. But as night falls, the heat vanishes into the vacuum of space, leaving the surface in a deep, icy freeze. Remarkably, in the permanent shadows of its poles, scientists have discovered deposits of frozen water ice that never melt. Peering deep inside, we find Mercury's most unusual feature, a disproportionately large metallic core filling most of the planet's interior. This giant iron heart makes Mercury the second densest planet in our system, a heavyweight champion in a small frame. This core generates a magnetic field, an invisible web struggling to hold back the sun's immense power. The solar wind, a stream of charged particles, constantly batters Mercury's thin and fragile magnetosphere. It is a delicate dance between a tiny world and its monstrous star, occurring millions of miles away from us. Mercury is also a world in retreat. These towering cliffs, called lobate scarps, reveal a planet that is actually shrinking. As the core cools and contracts, the rocky crust wrinkles and thrusts upward, creating miles of jagged, mountainous terrain. To understand these secrets, we sent the Messenger spacecraft to endure the heat and map the surface in incredible detail. Now, the Bepi Colombo mission follows, deploying orbiters to study the planet's composition and mysterious environment more deeply. Small, resilient, and enduring, Mercury remains a vital key to understanding how our solar system truly formed. As we look closer, this swift messenger reminds us of the endless wonders waiting to be discovered in our cosmic backyard.
Often called Earth's twin, Venus is a world of staggering beauty and terrifying extremes, hidden beneath a thick veil of golden clouds. To understand this mysterious planet, we must pierce its hazy upper atmosphere and descend into a realm of crushing pressure and searing heat. From Earth, it shines as the morning star, the brightest object in our twilight sky, a serene beacon that belies its true nature. Venus is wrapped in thick clouds of carbon dioxide and swirling mists of sulfuric acid, where lightning flickers through the toxic gloom. This dense atmosphere creates a runaway greenhouse effect, trapping solar heat and making Venus the hottest planet in our solar system. On the surface, temperatures reach 900 degrees Fahrenheit, hot enough to melt lead, casting everything in a dull, oppressive orange glow. Amidst the heat, the Maxwell Montes Mountains rise high, their peaks potentially coated in a strange, metallic frost of heavy minerals. Shield volcanoes like Sifmongs dominate the landscape, with slow-moving rivers of glowing lava carving paths across the scorched volcanic plains. Across the vast horizons, unique pancake domes of thick lava stand as remnants of a geologically violent and ancient past. In the upper atmosphere, winds race at hundreds of miles per hour, circling the entire planet in just for Earth days. At the South Pole, a massive double-eyed vortex churns endlessly, a testament to the planet's chaotic and powerful weather systems. Unlike most planets, Venus rotates in reverse. On this world, the sun rises in the west and sets in the east very slowly. The atmospheric pressure is 90 times that of Earth's, equivalent to being a mile deep in the ocean, enough to crush a steel probe. Humanity has braved these conditions with the Soviet Venera probes and NASA's Magellan, using radar to map the surface through the clouds. Yet, high in the temperate clouds, some scientists wonder if microbial life could exist, drifting in the only habitable zone of this world. Venus remains a cautionary tale, a beautiful yet lethal reminder of how fragile a planet's climate can be when balance is lost. As we peel back the layers of our mysterious twin, we find a world that challenges everything we know about planetary survival.
Suspended in the silent void of space, Earth appears as a fragile oasis, a shimmering jewel of blue and white against the darkness. As we draw closer, we encounter the thin, protective veil of our atmosphere, the delicate boundary that makes all life possible. Where land meets the sea, the relentless energy of the tides shapes our world, creating a dynamic landscape of constant change. High above, massive storm systems swirl with immense power, driving the global weather patterns that sustain the planet's diverse ecosystems. From the morning mist, rising in ancient forests, to falling mountain rain, the endless water cycle nourishes every corner of the globe. The icy crowns of our poles act as a global mirror, reflecting the sun's heat and regulating the Earth's delicate temperature balance. Within the emerald heart of tropical rainforests, life thrives in an incredible web of biodiversity, protected by a dense sun-dappled canopy. Across the golden plains of the savanna, the rhythm of life follows the ancient migrations of wildlife under a setting sun. Beneath the waves, coral reefs explode with color, hosting a vibrant underwater world that is vital to the health of our oceans. Deep beneath the surface lies a world of fire and pressure, where a molten mantle surrounds the planet's solid iron core. This internal energy erupts in spectacular displays of power, constantly recycling the Earth's crust and forging new land. Over eons, the slow collision of tectonic plates has pushed massive mountain ranges toward the sky, sculpting the planet's majestic skyline. As night falls, the spark of human civilization becomes visible, a glittering network of light connecting people across the continents. From parched deserts to frozen tundras, every landscape is a vital part of a singular, interconnected system where all life is linked. Looking back from the moon, we see our home as it truly is, a beautiful and lonely outpost of life in the cosmos. This is our only home, a miracle of biology and physics dancing through the silence of space, deserving our ultimate care. Let us cherish this vibrant world, for in the vastness of the universe, there is nowhere else quite like Earth. Mars, the red planet, a world that has captivated human imagination for centuries, standing as a beacon of mystery in our night sky. Behold Valles Marineris, the grandest canyon in the solar system. Reaching depths of 7 kilometers, its scale and staggering depth are truly breathtaking. From the perspective of its tiny moon Phobos, the planet looms large, a testament to the lonely majesty of our celestial neighbor, but Mars wasn't always this dry. These ancient riverbeds and lake basins tell a story of a time when liquid water carved the Martian surface. 4 billion years ago, Mars may have been a blue world with vast oceans and a thick atmosphere that might have once harbored life. Today, that water remains locked away, shimmering in the polar caps and hidden within vast glaciers of ice and frozen carbon dioxide. Dominating the horizon is Olympus Mons. This colossus is the largest volcano in the solar system, so tall it pierces the very edge of the atmosphere. The chaos terrain reveals a violent past, where catastrophic floods once reshaped the landscape into a labyrinth of broken mesas and deep valleys. To the north, the vast plains stretch out a silent, dusty expanse scarred by the impacts of countless meteorites over billions of years. But Mars is not a dead world. Global dust storms can wrap the entire planet in an orange haze, obscuring the surface for months at a time. Towering dust devils dance across the desert floor, leaving intricate dark tracks behind them as they sweep through the thin Martian air. Our robotic pioneers, like the Perseverance rover, navigate these treacherous craters, tirelessly searching for chemical signatures of ancient life. We are preparing for the next great leap missions to bring Martian treasures back to Earth, bridging the gap between two worlds. Mars remains a silent invitation, a vast red frontier waiting for the next generation of explorers to step into the unknown. The day is coming when human footprints will finally join the tracks of our robots, beginning a new chapter for humanity on the red sands.
Welcome to the cosmic border. Beyond the orbit of Mars lies a vast, silent wilderness, the asteroid belt, a graveyard of lost and ancient worlds. Millions of rocks drift in the cold vacuum. Some are brilliant and metallic, while others are dark and rocky, each a silent witness to solar history. From the center of this belt, the sun appears only as a brilliant spark, casting long shadows across the rubble that separates our inner and outer planets. Over 4 billion years ago, a planet tried to form here, but Jupiter's massive gravity prevented the dust from coalescing, leaving behind these fragments of creation. What remains are pristine cosmic time capsules. These cratered surfaces contain ancient minerals that have remained unchanged since the very birth of the solar system. Many of these are not solid rock, but rubble piles loose collections of boulders and dust held together only by their own incredibly weak gravity. Among these ruins are legends like Asteroid Bennu. This spinning, diamond-shaped rock is a dark, cosmic acorn that may hold the building blocks of life. Its surface is a chaotic landscape of boulders and fine grains. These materials hide secrets about the water and organic molecules that once seeded Earth. Nearby lies Rugu, another rugged wanderer with a similar top-like shape. Its boulder-strewn terrain tells a story of billions of years of cosmic weathering. Humanity has reached out to touch these relics. The OSIRIS-REx spacecraft extended its robotic arm to Bennu, capturing a precious sample from the ancient world. Meanwhile, the Hayabusa 2 mission returned to Earth. Its capsule glowing orange as it brought back grains of Rugu that traveled millions of miles through space. In sterile laboratories, scientists now examine these tiny black grains. This is our first direct touch of a world that existed before our own planet. The belt is also a treasure trove for our future. Rich in nickel and iron, these asteroids could one day provide the resources for deep space colonies. But we must also learn to defend ourselves. Missions like DART demonstrate how we can intentionally deflect asteroids to protect our home planet from collision. Today, the asteroid belt is seen as a vast treasure map of space, a shimmering ring of light and shadows surrounding our inner solar system. By studying